So if we have, so the way we tell if we reject or fail to reject, or if we have or if we lack evidence, is by the p-value, right? Comparing the p-value to the alpha level. So if we have a p-value that's smaller than alpha, we're always going to reject. Therefore, we have significant evidence or sufficient evidence to suggest that, and then we put this in context, in words. We got to change that to words, whatever the null or the alternative hypothesis was. If the p-value is too big, if p-value is too big and it's bigger than alpha, we always fail to reject, and therefore we lack sufficient evidence. Okay, so that's how it goes. That's how it always goes. You're never going to have a p-value bigger than alpha and reject, or you're never going to have a p-value that's smaller than alpha and fail to reject. It'll never work that way. Okay, it'll always follow that color code. Okay, so we stopped right there, and then we didn't get a chance to answer question B of it. Question B. Now they won't ask you to do this a lot, but it is something that they might ask you to do. So I always put it in the notes. I might. Okay. If I do, it'll be like one time. But I mean, it's a 2-point question. Grading the tests, 2 points could be the difference between A or B, right? So you want to make sure that you're ready for it. It's not hard to do, but it is something you have to account for. Okay. So interpret the meaning of the p-value. So pretty much the p-value, that guy right there. In words, what does that number mean? In words, what does that number signify? That's what you're saying. Okay. If you look a little earlier in the notes, I put a sentence frame. There's a sentence frame on there. That helps you interpreting the p-value. So what this means is you only have to do this when asked. It's not part of a test. This is not part of the test, but only when asked separately to do it. If the null hypothesis is true, so if their claim, right, the null hypothesis is always the claim. If the claim is true, if what you're telling me is true, this is the probability that a statistic, either p hat or x bar, right, just depending on whether it's a means or it's a proportions question, at least as extreme as the observed value would occur. Okay, so what it's saying is, if the null hypothesis is true, this is the probability that my sample would be what it was, right? So what this is saying with our 2%, right? What it's saying is if their claim is true, and what was their claim? Their claim was, how effective was it? 62%, right? Their claim. So if their claim is true, if it is indeed 62% effective, then the chances that I would have gotten a p hat of 0.5676 is that big, right? So what we're trying to say is this number is so small that it couldn't have happened just by chance. There has to be something to it. So that's why we rejected it, right? If it was bigger, then we would fail to reject, right? So if what they're saying is true, if 62% of the vaccines produced, this vaccine is effective, the chances that I would get a p hat of the same proportion, 0.576, is less than 3% chance. That's pretty small chance, right? So because it was lower than our alpha level, we say, we reject your claim. Your claim must be wrong. Your claim has to be wrong. If there was a 3% chance of me getting a sample and that being it, you're wrong. You got to be wrong. It has to be wrong. Okay? Your claim has to be wrong. So that's what that is. So how do you put it into words? Like I said, it's kind of tricky, but that's essentially what it is. So start out with, if the claim is true, or if H sub 0 is true, or if the null hypothesis is true. Okay, let's see. If is true, if this guy is true, then the probability, because p-value means probability of my p hat is, and then you put the p-value in there. Was it 0.026, something like that? If what they're saying is true, then the probability of me securing a p hat or me getting a p hat of that is very small. That's essentially what you're trying to say. Okay, so really what you're trying to do is you're trying to compare p hat to p, or mu to x bar, whatever you're trying to do. That's essentially what it's doing, because that's what that's doing here, right? This is a number that is calculated by comparing these two guys, right? That's the first thing we do on top, right? We subtract them, right? So that's what it's doing. It's comparing these two guys. So these two guys are so far apart that the only probability here is less than 3%. Okay? That's what it's saying. That's what that's saying. All right. Okay, so let's do another one. Let's do another one all the way through. Okay, there's a reason why, like I said, the last two are special types, and I forgot I forgot to put this one in. So this one should have been right after the question we just did. So after that slide that says carefully interpret, this slide right here, it should have been this slide here, but for some reason it didn't come out. Okay, so yep. Okay, so again, we're going to read it, we're going to pull from it what we can get. Okay, we're going to read from it and pull out everything we need. All right. A recent report states that 55% of US adults use Netflix to stream shows and movies. An advertising company believes the proportion of California residents who use Netflix is greater than the national proportion. Because Netflix's headquarters is in Los Gatos, California, the company selects a random sample of 600. So the advertising company selects a random sample of 600 adults from California and find that 360 of them use Netflix. Is there convincing evidence at the alpha equals 0.05 level that more than 55% of the residents use Netflix? Okay. All right, so now let's pull stuff from it. What's important? You guys know what we're going to need. So what's important from here that we could use? All right, so let's do that first. Yep, 55%. That's the national proportion. So that's definitely going to be P. Yep, it's right next door to San Jose. It's like Fresno, Clovis are right next to each other. It's like San Jose, Los Gatos. There's a Campbell is right there. Yeah, there's like a little cities. It's very affluent, very big houses. But yeah, it's right outside of San Jose. And is, say it again. 600. Good. Good. Our sample is 360 over 600. Yeah, you can tell what our alternative. What is our alternative hypothesis going to be? We don't have to write it out yet because we're going to do that. But what is it eventually? What is our alternative hypothesis eventually going to be? Greater than, yeah, because right there, more than. It's written right there, the question right there, and it says it right there, greater than, right? So eventually when we get there, we're going to put greater than, right? Okay, so let's change p hat to a decimal. What is it as a decimal? 0.6. All right. One more piece, alpha level. That's also a part of it, but it's also important. Our alpha level is 5%. Okay, and it is proportions. Yep, that's always important. All right. Okay, so let's get started. So the first step is a population parameter. Since it's proportions, we're going to start it as p equals true proportion or the true proportion. So what is that 0.55? So we're trying to, in words, what does 0.55 mean? True proportion. There you go. True proportion of all US adults who use Netflix. Okay. Done. Okay. Hypothesis. Now we're going to do hypothesis. Hypotheses, I should say, because there's two of them. The null hypothesis, H sub 0, is always going to start for proportions P equals. And then we know that. We said P equals 0.55. And then we said our alternative. We have three options. Greater than, less than, not equal to. We said this one's going to be greater than because of the wording in the question. It says greater than in the prompt. Several parts. A couple times it says greater than, right? Okay, I'm going to put significance level here. Significance level, 5%. Okay. You don't have to go in order, the steps, right? You don't have to go in order of the 7. Like I don't take off points because you put, obviously the conclusion is going to come last, but if you put the level of significance before hypothesis statement, or you put the formula before one, or, that's fine. So the next one is our formula. Which test statistic are we going to use? We're going to use the same one we did last time. We're going to use, or is it this guy here? Again, the bottom is given. The bottom is on your formula sheet. We've been using the bottom since chapter 7, and it's on your formula sheet. The top is just p hat minus the claim, p. P sub 0 is the same thing as the claim. Sometimes they put p sub 0, sometimes they just put p. It's the same thing. Okay. Let me write it down. Let's see. Test statistic. Z equals p hat minus p. And then square root p1 minus p over n. Okay. Next step, before we do our calculations, we have to do our assumptions. So we're going to do our conditions assumptions. Okay, the first one is an SRS. Second one is 10% condition. Last one is normality. Yeah. So let's see, the sample was obtained. Let's see. It says a random sample, so stated. 10% condition, small n is less than 10% of big N. Well, we know small n, lowercase n we know is 600, because we said that earlier. 600. So 600 less than 10% of big N. We don't have a number for big N, but what will we put here? Not all US adults, close. Not California. There you go, subscribers. Netflix subscribers in the US. Yeah. All US Netflix users or subscribers. That's where P comes from, right? That's what we want there, where P comes from. Okay. And then the last one, normality. We get okay, so 600 times 0.55 is 300 and something. 330. And then 600 times 0.45 is the rest. So it's 270. We're good there. Okay. Okay, we've got two more, calculations and conclusion. Okay, so calculations. We're going to draw our picture. For confidence intervals, you don't need a picture. For hypothesis tests, you always need a picture. Okay. Okay, so what's the middle of the curve going to be? There you go. Our p hat is going to be the one we graph. So our p hat was 0.60. And we said greater than in the alternative. You look for the alternative to see which way you're going to shade. In the alternative, it said greater than, so we shade greater than. Okay. Okay, now z. Z is p hat minus p. So 0.60 minus 0.55. Then we have 0.55 times 1 minus 0.55 over 600. And again, from here, you can crunch those numbers. You don't need a fancy calculator to crunch those numbers. Any scientific calculator will work there. Or once you show that, you can go to the TI. The TI will give you another way to do it. I'll show you again. I showed you yesterday, but we'll do it one more time. Okay. So if we want to do a test or an interval, a confidence interval or a test, we go to stat, tests, and then we find the one that we want. We want to test, right? We want to test And we said that, I think we said number 5 was the best one. Yesterday we said number 5 for this one, one proportion, z-test. That's what we want, okay? So we need to put in the claim. Their claim was 0.55. Now they want to calculate p hat on their own. So we have to give them the numerator and the denominator. So x is the numerator. So the numerator was 360. The denominator is 600. Together they make 0.6. And then here we said greater than. Okay. So you have two options: calculate, draw. Calculate gives you a little more data. Draw gives you a picture. It doesn't matter. They both will give you the same in terms of what we need. Okay. So our let's see, our z-score for that. It's important to write down the z-score, 2.46. And then right under is the p-value, 0.0069. And then p hat is 0.6. We already knew that. And n was 600. We already knew that. Okay. All right. So that's our calculations. The last step is our conclusion based off our calculations. Our conclusion needs three things. The first thing our conclusion needs is we need to compare what was p-value and what was the alpha level and which one was greater or less than, or what happened there. Okay, so we're going to put since since the p-value, then we're going to write it in here, 0.0069. So is our p-value going to be smaller or bigger? Smaller, yeah, quite a bit smaller than alpha, which is 5%. So since the p-value was smaller, are we going to reject or fail to reject? We reject, again, the null hypothesis. So I combine two things in one. The first part, comparing. The second part, reject, fail to reject. And then the last part, since we rejected, therefore, we have sufficient evidence to suggest, and then this is where we put the alternative in words. So we said the alternative in numbers and symbols, but we need to say it in words. So the alternative is p is greater than 0.55. So how do I say that in words? P is greater than 0.55. But instead of saying p, I say what p actually stands for. There you go. Yep, exactly what you wrote right here. The true proportion of all US adults who use Netflix is greater than 0.55. .55. Done. Okay. Anything else I forgot? I don't think. Okay. All right. So that was just a normal type of test. That's what we call there is it's called a one-tailed test. One-tailed test because we only shaded one side. The next one we're going to do is called the two-tailed test because we're going to shade on both sides, and I'll explain why, okay, when we start to get to it. So let's look at the one. So it's the next one in your notes, the ones I gave you yesterday. So let's go back to those. Okay, so read the question. Pull out what we need. So according to the Association of American Medical Colleges, only 46% of medical school applicants were admitted to a medical school in the fall of 2006. 2 years later, a random sample of 180 medical school applicants was taken. 77 of those were admitted. Okay, so we're going to use this data to show, does this data provide evidence of a change in the acceptance rate at this college? Okay. So what information could I pull that would be important? 46%. Yep. What is that going to be? P. Good. That's the claim. 46%. Good. What else do I know? P hat. I know P hat. What is P hat going to be? 77 over 180. Good. What else do I know? N is 180. It's a proportions question. Very good. Yeah, what's our alternative going to be? There you go. This is a not equal. What leads us to say this is going to be a hypothesis alternative where we don't say greater than or less than? It's just not equal. There you go. Right there. Perfect. A change. It doesn't say what the change is. Great. Like in the last question, it was more, it's a greater than, right? There was obvious. This one just says a change. So if it just says a change, that's when we use not equal to. Okay, so when we get there, that's what we're going to do. Okay. Okay, so alpha level, does it say alpha level anywhere? Nope, so 5%. Okay. Okay, so let's start with population parameter. P equals the true proportion. So 0.46, who does that number represent? What does that number represent? The true proportion? Admitted medical school applicants. There you go, perfect. Perfect. True proportion of admitted med school applicants in fall 2006. Perfect. Because we're going to use that later. We're going to literally cut and paste into our conclusion later. So that's why we always state it at the beginning. Okay, so hypotheses. The claim is 0.46. We said not equal to because it said just a change. Has that number changed? Not for the better, not for the worse, just changed. Okay. Significance level, we said is 5%. Okay. Okay, so now let's do our conditions assumption, or no, test statistic, sorry. Test statistic, it's going to be the same one we're using. We've been using the last two problems. Z equals p hat minus p. Okay. Conditions assumptions. Okay. So the random sample of 180, it says it was a random sample, so we're good there. So we can say stated. 10% condition, 10% condition, n is less than 10% of big N. So we said small n was 180. So if 180 is the sample, who was the sample taken from? There you go. All med school applicants. All med school applicants. We don't have a number for that, so we're going to assume that that number is big enough. And then the last one. So since it's proportions, it's NP, n times p greater than 10, and n1 minus p greater than or equal to 10. So n is 180, p was 0.46, and then 180.54. So 180, it's going to be 80 something. Thank you, 82.8. And then this one over here is going to be 90. Perfect. Okay. All right, last two steps. Calculations and conclusion. Okay. Calculations. Okay, so first thing we do, draw a picture. Okay, so what's going to go in the middle? 0.46. The claim always goes in the middle. Our p hat was what? 0.428. I don't think I wrote that up here. 0.428. So we're going to go and 428 is probably right about here. Okay, so then we looked at the alternative to say, do we shade above or shade below, right? We looked to see if we shade to the left or shade to the right. But we don't have a greater than or equal to, or sorry, greater than or less than, right? We don't have that. We have different. So this is what you do. This is the difference here. It's called a two-tail test because we shade towards the extremes. So here, we always shade towards the extremes on two-tail tests. So here is our value, and we're going to shade towards the extremes. So we're going to shade towards the edges. So this one, we're going to shade towards the left. Where does the other tail come from? Well, the other tail comes from the same distance.
Okay.
So what we have to do is figure out what's the distance here? So we go 0.46 minus 0.428, and you get 0.032. So then we have to add 0.032 here, and what do we get?
0.492.
There you go. And we shade towards the extremes again.
Yeah.
So what's true about those two green areas? They're both exactly the same size. They're just doubled. So if you tell me what one green is, I can double it and make the other green one. Or you can use your calculator, and your calculator will add them up for you. Okay, I'll show you how to do that. So p-value, z-score. When we do the z-score, we only do it with the given data. So the given was 0.428, right? That was the p-hat that they gave us. And then what was it? 0.46, 1 minus 0.46 over 180, right? So if you're going to use your tables, that's fine. Got to double it though, double the green, because you also have green on the other side. If you use the calculator, it'll do it for you. Okay? Both are okay. I don't mind which one you do. It's always good to use tables because you're going to need to know how to use the tables. But since you have the calculator, we can also use that as well. Okay? So let's go to the calculator. Same test, same nothing, same everything. Nothing has changed. Only one part's going to change. Okay, so we got our claim is 0.46. The numerator for p hat is 77. The denominator is 180. That's n. We're going to select this guy right here, the not equal to. Okay. I'm going to hit draw just to show you that it's the same picture. See, it's the same picture that we have on our paper. This z-score was for the one we put in. So this z-score was for our p hat. So the z-score is negative 0.87. The z-score for the other side would be positive 0.7, right? And then it says our p-value. Our p-value is almost 39%. Our p-value is almost 39%. That's both added together. That's both greens added together. Our calculator does them together. If you do them using the table does one at a time. Okay, so that's the difference. So that 0.3857 represents both blues. Okay, so how do I figure out what each green was then? Divided by 2, yep. Divide your p-value by 2. So if I cut it in half, we get 0.19285. Okay, so each of them was almost 19%. Pretty big. Together, they're 0.3857. Okay, so before we go into the conclusion real quick, because this is where I see students make the mistake or they forget. How did I get the other side of a two-tailed? What did I do to get the other side? I know how I got this one. This one came from the question, right? So I shaded this way. But how do I get the other side? Yeah, so how did I get 0.492?
0.46 minus 0.428
Found the distance here.
and added it.
Instead of subtracting it from 0.46, I added it to 0.46 and I got that there. Okay. So if you have a, where is it? If you have an alternative hypothesis that's not equal to, you better have shades on both sides. Okay. Okay, so last thing is conclusion. Since p-value 0.3857 is greater than alpha level or significance level of 0.05, quite a bit bigger. Are we rejecting here or are we failed to rejecting here? Fail to reject. Yep, too big. P-value is too big. We fail to reject the null hypothesis. We don't have enough information to say it's wrong. It's kind of like saying not guilty. You're not saying the person's innocent. You're saying I don't have enough evidence to say they're guilty. Right? Okay. Therefore, we lack sufficient evidence to show the alternative hypothesis. So we go back to the alternative hypothesis. The alternative hypothesis said P is not 0.46, right? What is P? The true proportion of admitted medical student applicants. To show that the true proportion of med school applicants in fall 2006 is changed or is different or is not 0.46. Any one of those is work. Has not changed from 0.46 or is not 0.46 or is different than 0.46, whatever you want to say. Okay, we don't have enough information. Now, could it have changed over time? Yeah, but our sample, there wasn't enough data, there wasn't enough evidence in our sample. So anywhere in there, do I say they're correct? Anywhere in there, do I say that their claim is true? No, we never accept their claim. We only say, yes, they are wrong, or no, we don't have enough evidence to say they're wrong. We never say they're right. We never accept what they give us, okay? All righty. All right. Okay, so I'm not going to assign anything yet. I'll assign it for you guys tomorrow because all we have is one more question, and then I'll give you some time to start the assignment in class. Okay? Yeah, I'll take everything. Yeah.